In today's video, we are going to discuss inverse trigonometric functions. We will discuss about the graphs, we'll do analysis on the graphs, we will study the range and domain. So let's start with the first one. The first one is sine inverse x. The graph of the curve y is equal to sine x is something like this. And to find the inverse of this function, we consider a line y is equal to x. On taking the image about the line y is equal to x, we get the red line, which is graph of sine inverse x. Now let's zoom in this portion and study why we consider only from minus pi by 2 to pi over 2. We consider the graph of the sine x from minus pi by 2 to pi over 2 because in this range the graph of the sine x is invertible, so we can find inverse of that function in this range. Now on taking image with respect to the line y is equal to x, we get the graph of the sine inverse x something like this. In this case, the domain of the graph sine inverse x is from minus 1 to 1 and range will be from minus pi by 2 to pi over 2. Now let's move on to the next one. The next one is cos inverse x. As we know that we have to find the graph of cos inverse x, so we need the graph of the cos x should be invertible. So we consider the range from 0 to pi, and now on taking image with respect to the line y is equal to x, we get the graph of the cos x something like this. In this case, the domain of the function will be from minus 1 to 1 and the range will be from 0 to pi. Now let's move on to the next one. The next one is tan inverse x. As we know, the graph of the tan x looks like this. And for taking the inverse of y is equal to tan x, we consider a line y is equal to x. On taking image of the graph y is equal to tan x, we get the graph of y is equal to tan inverse x. As we know that for taking inverse, the graph should be invertible, so we considered from the range minus pi over 2 to pi over 2. In this case, you can see the domain of the function y is equal to tan inverse x is from minus infinity to infinity with open pi over 2. So pi over 2 will be with open end. Now let's move on to the next one, the cot open end. Now let's move on to the next one, the cot inverse x. In this case, similarly, we know the graph of cot x, then we will consider the image with respect to the line y is equal to x and we will get the graph of cot inverse x. At x is equal to 0, it cuts the y-axis at pi over 2. Now let's consider the domain and the range. The domain will be from minus infinity to infinity and the range will be from 0 to pi. Now let's move on to the next one. The next one is sec inverse x. As we know, the graph of this y is equal to sec x looks something like this, and we know that we have to find the inverse of the graph sec x. So we will consider the graph of the y is equal to sec x from 0 to pi, because in this range the graph of the y is equal to sec x is invertible. Now on taking the image with respect to the line y is equal to x, we get the graph of the sec x something like this. The domain is from minus infinity to minus 1 close union 1 close to infinity, and the range you can see 0 to pi by 2 open union pi by 2 open to pi closed. Okay, now let's move on to the next one. The next one is our last one, which is cosec inverse x. And find the inverse of the cosec function, we consider the range from minus pi by 2 to pi by 2 because in this range the graph of the y is equal to cosec function is invertible. So finding the inverse, we consider the line y is equal to x, and on taking the image of the graph y is equal to cosec x in the line y is equal to x, we get the graph of y is equal to cosec inverse x. And in this case, the domain of the graph cosec inverse x is from minus infinity to 1 union 1 to infinity, and the range you can see minus pi over 2 to 0 union 0 to pi over 2. I hope you got this. If you like this video, please make sure that you subscribe the channel for more such videos. See you in the next one. Jai Hind.